Hi everyone, and welcome back to CogX 2020. We are on the Gen Z or Gen Z stage, depending on how you want to go with that, for a brand new session, careers in AI and other uses of STEM subjects. We've got an amazing jam-packed panel, so we'll kick straight off into that. And I'll introduce our moderator for this session, Sunaina Aytan.
Hey all. My name is Sunaina, and I'm a cybersecurity analyst working at eSecure. And yes, I'll just be going through the session, introducing our speakers, and doing the questions for the Q&A later on. So we'll start off with Alexandra Malyshev. So he studied computer science at Moscow Institute of Physics and Technologies. Is the co-founder and company leader of Steinbeis AI Consultancy Center, and is also named as one of the top 50 hackers of 2020. So I'll hand it over to you, Alex.
That's quite inspiring, actually, to present in front of the audience. So yeah, okay. Wow. I will share the screen. So right before we start, I would like to see the profile of our viewers today. So I would like to ask you to go to the menti.com website and type there just 6 numbers. It's 50 85 07. And then you type this. You can select which major profile do you have at this moment. So I will do it together with you. So I can go to the menti.com, and then I can just enter the code. The code is 508507. And then if I open this, I can just select that I'm a software developer, and I'm a data scientist, and at this moment I'm an entrepreneur. So I can submit my results. And if you submit your results, then we can see who are you, the audience. So this, we have like a few minutes, so I would like you to do that. Okay. Yeah, amazing. So we have few more votes. So we have some non-CS students as well. So feel free to use menti.com and type the code there. Okay, we have more software developers. Yeah. Cool. So okay. So yeah, that's nice. So we have very competitive topics from like CS students to non-CS students. Also, we have some entrepreneurs here. We have some software developers as well. But I think like the major part are relevant to the CS. Okay. Let's wait just a few more minutes. So we have 18 participants, 19. Wow, that's amazing. Okay. So we can go back, I think, in few minutes back to the Menti. Just feel free to vote later, and I would like to switch now to the topic of my today's discussion. Yeah, so my topic is like from a star hackathon hacker to AI company, and how hackathons boost innovations. So my career has started when I was a software developer, and I've started coding and also making some data science projects. Today, I'm the executive officer and the company leader at Steinbeis AI Consulting Center. We help different companies organizing and implementing some AI as a service. And I'm also a professional hackathon attendee. I've been to many different hackathons. I also a well-known organizer. I have my own software community about hackathons, actually. And in the 2020, I was awarded by Major League Hacking as one of top 50 hackathon hackers in the world. So what I do at this moment, so I help different companies with making AI, and running this consultancy has helped me a lot. Then I have started attending different hackathons, and then I have started with my first one that has completely changed my life. And before we go to my story, I would like to make an accent on few things about the modern world and Gen Z especially. So the main thing is that 80% aspire to work with cutting edge technologies, and the Gen Z audience, they're more likely to start their career early, and they also understand that half of them will not have their job after 20 years, so their job will just disappear. And this statistic just yielding to the following sentence that the world is changing so rapid and you need to think fast, you need to develop new ideas, you need to implement that, because in 20 years, you probably will have another job and they maybe have another topic. And that's the crucial thing, I think, in my discussion. So if you had started your company in 76, so you could do that in-house, you could do it very expensive and quite slow. So it was quite okay to spend 10 years in a row building your startup. Today in 2020, you have remote jobs, you have cheap software developers, and they're also worldwide available. Today, if I need to do something, I go to the GitHub, I don't go to my garage. I find a ready source code, I make a small prototype, and the development is making me so fast, and I can test my ideas. And that's the main change from like 30 years perspective. And one of the topic I'm more familiar with is AI. So I've been studying AI. I'm doing a lot of different projects in that topic. And if you want to see how the AI has started in 80s or in 90s, it was well known only in the world of scientists. And maybe in the beginning of our century, some recommendation systems has started. But the idea is that some of the modern machine learning technologies are becoming more and more common. For example, computer vision. So can you imagine that a state-of-the-art technology could be outdated in just 5 years in 76? Well, today it is quite okay for us because, for example, the image recognition and the face tracking technology, which was quite popular in the research world in 2014, now begins more and more ordinary thing because Facebook, Google, Apple, all of them, they are making AR programs which can help creators to build their own face tracking services. And that begins with different tools. And now it makes more and more affordable. And like from 2 to 5 years, the coding is just can make something new to more casual. For example, if I just go out of my presentation and I would like to show you something, that the snap camera, for example. So I can just can become a cat in a second, and I can present my this technology at the live stream. I can even become a potato and start telling you about the scientific approach in the same road. And this how the technology is making everything. So in 5 years, it was just state of the art. Today, it is a common thing, and you need to develop something new. And I just want to show you some analogy with my story. And I was thinking about that I'm doing something very casual when I've been a software developer. I was only thinking about the planning of my sprints with the agile technology. I was thinking about some design, building, testing, reviews. That was continuous for ages. But somehow I was also thinking about the products and how they can change their mind of the consumers. And I have started attending different hackathons. And hackathons are helping me today is just to drive some innovation. Just for some audience who are not really familiar with that topic, hackathon is like a IT competition when teams from up to 5 people coming together and they coding something without any breaks for 36 hours. They want to create a product and to show this product as a small startup. And at my first hackathon, I understood one simple thing. If I want to spend a lot of time for making casual things at my job, why I can't get the value in 36 hours? And then I have started thinking, okay, if in 36 hours I can drive some innovations, shall I solve a task in weeks? Well, the answer is yes, because you can create the value in 36 hours, but you still need to drive these tasks in weeks. But if you start thinking that you want to solve a task in weeks, that means that you can spend years to solve tasks, not to generate some value. And that's the crucial thing, that you can create not only fast, but also valuable products. And if you compare building a product, like you make your own pyramid, it's like then you start with not just the ready product, but with a short prototype. You can deliver new value with some new features, and step by step, that makes completely different effort. So instead of then you go for the traditional coding, then you start with your customer, asking him about some technical aspects, software development, and then in final thing, you have your things done. You need to spend several months to do that. And I realized that this pattern is extremely good for consultancy. It is extremely good for making your own IT agency. And if you want to drive your software development, you have to think like that. You have to think in prototypes, not in products. You have to think about the value and how to improve the value. You can avoid different technical details, but the value could be delivered in days. And in the theory, it's also known as making proof of concept instead of prototype or a pilot. So you just create a small isolated thing, then you make it bigger and bigger. And the final thing, that makes your client happy and that makes you happy. So it helps you to create the innovations faster. And that's not only about the innovation, but also about your team. When I've been attending to different hackathons, I realized that then you start thinking in more iterative processing. Then you also need to think about your team. You want to keep it still small to test ideas faster. And then you do it again and again. I understood that after hackathons, the strongest team is the team with cross skills. So in example, we won this hackathon at Startup Weekend Techstars because all of our team members, all of them, they had cross skills. Almost no one were thinking only about technology, but also all of them were thinking about the product. They were thinking about the pitch and about the making the website. They all were thinking about some backend components and sales. And this is also a very important thing, because then you have your cross skills in the team that can also help you to transfer the learn of one example or one hackathon or one corporate client to many others. And in my story, it was like that. So we did, at this hackathon, actually, we did AI art, that's for some people, I think that's crazy, but AI can also create some art. And we have created the art. We have also sold several paintings. And then we were thinking at another hackathon, how it can help you. Some of my team member, he proposed, oh, we can use exactly same algorithms for predicting oil pumping. And when we talk about some oil and gas well logging problem, we can use the same approach. And then I talk about the cross skills. I mean this. Then you think about AI art, and then somehow you understand that same approach can be used in the oil and gas. And then you start thinking like that, you are becoming a real hacker, not the hacker who cracked the system, but the hacker who hacked the brain, who hacked the ideas and propose new technologies breakthrough technologies. And step by step, then you have this AI art project, then you have the oil and gas well logging project. So you can start with your potential client. And it was, for example, our case in the consultancy. Then we have started with a small team, and then we have proposed this approach to our oil and gas company, and we got the results. And after we got these results, we also understood that some of these components could be used in completely another story, in industrial machine learning. And industrial machine learning, for example, we went to several hackathons about predictive maintenance when some machinery can broke and you want to predict like what's the chance of this defect. And we went to the Bosch hackathon, for example, in Berlin, and we have proposed the close approach to the one we had in oil and gas, and we have started predicting bad defects. And this gave us the very high outcome because the colleagues of Bosch, they told us that our solution were rather better than in their production. And summing up, I would say that this is not the last example of how you can use your cross skills for making money and making new good projects with your team, but it's also about boosting the innovations. This all can also be applicable for your corporate team. For example, your team members can run your own internal hackathon or any other IT contest and start thinking like that. And summing up, I would emphasize your attention to these 4 components about what I have learned about software development in 2020. And today, these 4 knowledges, such as a go-to-market time, can help me with running some different applicable solutions in my AI consulting center. And if you have any questions, we can discuss them during this Q&A session after my pitch. And you can also reach me via LinkedIn with this QR code. You can scan it with your mobile phone or find me via search Alex Malyshev or via Alex M Security. I would lovely answer all your questions. Just text me. Okay. So I think at this point.
Thanks for that. I think when you were stressing about having cross skills, that really stuck to me. Coming from a technical team, you realize how important it is to be able to converse with people with soft skills and technical skills, and how important it is just to build up your technical skills, but your communication and your teamwork skills too. So like Alex said, if you have any questions, then please save them, because we will be asking doing a question and answer panel later on. So please save them for that. And we are now going to introduce Adam Kucharski, who is an associate professor at the London School of Hygiene and Tropical Medicine. Okay. Hey, Adam.
Hi.
Give you a second to introduce yourself.
So I'm an infectious disease epidemiologist at London School of Hygiene and Tropical Medicine. And what I want to talk today about is how things spread and what are the ideas and the skills that we can use to understand that. I think contagion is a topic that obviously are really shaping our lives at the moment, but I think it's not just going to be biological contagions that we're going to see, particularly over the coming months and years. In terms of importance, I think the ability to kind of understand what's driving this transmission, what things we can potentially target, not just for controlling things that are harmful, but also if there are beneficial messages, ideas, innovations we want to spread, really what are the kind of techniques that we can use. And in our group, in many others at the moment, obviously with COVID-19 circulating globally, we're working a lot on trying to understand what these drivers are and what it might mean for the epidemic. I mean, a lot of early work we did, we were one of the first groups to publish evidence that the lockdowns in China had worked, and that was a kind of feasible technique for bringing transmission down. We published early estimates on severity, suggesting that the fatality risk was probably about 10 times worse than flu. More recently, we're working a lot on real-time estimates of transmission in different areas. We've got global dashboards. We look at how much underreporting there is, which countries are missing their cases, what might be needed for things like contact tracing and these more targeted measures. But my background didn't start in biology, it didn't start in medicine. Originally, it started with mathematics. And one of my kind of early encounters with a very, very dramatic and dangerous form of contagion wasn't with an outbreak. It was actually in 2008. So in the penultimate year of my university course, I interned in finance, in derivatives trading for an investment bank. And that, of course, 2008 was the summer where the financial system really went to the edge. It was a summer that would end with Lehman Brothers going under. And the experiences for me that summer led me to pursue epidemiology and kind of the study of diseases as a course. It was something I'd done previously as part of my master's degree. I'd encountered these ideas about how do populations interact and what can drive transmission. But as I was leaving banking to pursue research in this area, a lot of the ideas from epidemiology were making their way into the financial industry to try and understand this crisis that had emerged in 2007 and 2008. And a lot of central banks particularly became interested in this. A lot of people who would subsequently become my colleagues would end up working on it, and would notice that really there were features of the networks that in hindsight made contagion far more likely. I think the approach prior to 2008 was very much viewing banks as individuals, and it's much the case of if you were trying to treat an infectious disease outbreak by viewing infections as individuals unlinked to others. That's, of course, not how contagion works. Contagion is about links and about connections and which of those are more and less important. And it turned out that the financial network prior to 2008 actually had a lot of features that epidemiologists had known about for decades as being more risky. So one, for example, is if you have a network where you have highly connected individuals connected to other highly connected individuals, what you'll typically see is an outbreak that spreads very quickly in those highly connected popular groups, but won't spread across the whole network. In contrast, if you have a network where you have highly connected sort of popular individuals, or in this case banks, connected to a lot of smaller and less connected individuals, you see an outbreak that's slower initially, but will permeate through a much larger amount of the network. And that was something that we had pre-2008. We'd also ended up with a financial system which had a lot of hidden links. A lot of these trades were made what's called over the counter. It wasn't made through an exchange. There was no visibility on those routes of transmission. And obviously, if you have a lot of links that you don't know about, as we saw in the early stages of the current COVID outbreak, cases passing unknown between countries, you can much more quickly end up with a larger contagion problem than you're initially aware of. I think these links between different forms of contagion are becoming increasingly important. SARS back in 2003 infected just over 8,000 cases and will cause about $50 billion of damage. So obviously at the time, relative to the outbreak size, that was an enormous cost. I think what we're seeing now will be many orders of magnitude larger than that. But after the 2008 financial crisis, Andy Haldane, who was based at the Bank of England, he's now the chief economist there, made this quite nice analogy between the two forms of contagion. He said that if you have an outbreak, there's two typical reactions that people will have. One is what he called a flight reaction, that people will leave to try and avoid the contagion. We've seen that in areas, for example, that were introducing quarantines in India and Italy. People will move as quarantines come in to try and get away from the area that's affected. The analogy in finance is where people will sell off things that they deem to be risky. And obviously, both of these things can have a harmful effect on the outbreak. If it's a biological contagion, it can spread the problem further. In finance, it can cause a run on stocks, it can cause a declining market, so you can kind of amplify the problem as a result. But the other behavior he identified was slightly different, that what can often happen with infection and what we're all living through now is one where people try and avoid infection. So they will physically distance, they will be more cautious in their interactions. And that can have the effect of slowing down transmission, because it's less likely the infectious people will come into contact with susceptible ones. But the analogy that was happening in finance before that outbreak was one where people were essentially avoiding any contact with others, much like an infectious disease. But it led to a credit crisis because no one was willing to interact with anyone else, to trade with anyone else, because they didn't know where the risk was. And that, to a large extent, was what amplified and seized up the system. It was these confidence effects, it was these rumors, and it was this parallel spread of information that was really influencing what was going on. And that was something early on in this COVID outbreak that was very noticeable. I had a piece in The Guardian back at the start of February, noting that misinformation was probably spreading faster than the early outbreak. We saw a lot of these rumors emerging, some newspapers calling it snake flu, hypotheses that, well, not even hypotheses, just pure speculation that it was somehow some mutant version of an HIV virus that people had engineered. Really absurd claims, but spreading very quickly. I think that raises the question of how do we quantify that contagion? How do we say if something's spreading quickly or easily? And one of the values that we work with a lot, which I think is now familiar to a lot of people, is what we call the reproduction number. It's just for each event or each infectious individual, how much new infection or how many new events do they create? So whether it's a biological infection and you have one case that will spread the infection to a few others, whether it's a piece of online content and each person who shares it, it will be retweeted by a few others. And for the coronavirus, the reproduction number seems to be about 3, particularly in the early stages when you don't have good control in place. But what's remarkable is a study a few years ago by Facebook researchers looking at the most popular content on their platform between about 2014 and 2016. So this is kind of things like Ice Bucket Challenge, things that really high profile, a lot of people have done. On average, each person who posted or shared that content, it was reshared by a couple of others. So the reproduction number for the most popular content on Facebook a few years ago was about 2. So very similar to what the current coronavirus is. But there are 2 key differences. And I think this really can shape a lot of how we understand contagion. One is the speed. Something online, if it's shared, will be reshared typically within about 30 seconds, maybe a minute. Biological contagion, that same delay process, what we call the generation time, is typically a few days. For coronavirus, it's about 5 days. And that means that at the individual level, the amount of contagion that's being generated might be the same, but the timescale it happens on is why we may end up with a situation where information is spreading much faster than the biological contagion that it's speculating on. So that's one feature. The speed can be very different in these 2 forms of outbreaks. The other one, which certainly a lot of focus was drawn onto post 2016 with the US election, with Brexit, with a number of other political events, is the scale in which this happens. Because when we talk about reproduction numbers, we're talking about averages. We're talking about each person on average giving it to a couple of others. But of course, that's not how outbreaks work. Typically, you might see these so-called super spreading events where you have one infection and you generate a lot of secondary transmission. For example, our group have estimated for MERS and more recently for the coronavirus that probably about 20% of infections lead to about 80% of transmission. And largely that's the result of the places and the events and the environments that transmission can occur in. So we often see outbreaks in healthcare, in really kind of intensely interacting environments. But that does give us some intuition about how we might be able to contain these things. Because if we're talking about, for example, online content, and we have a handful of individuals or outlets that are amplifying things, changing that behavior can have a disproportionate effect on the outbreak. Likewise, for biological infection, if we can identify where these events are happening and put good infection control, that can give us a tool that enables us to have a disproportionate effect on reducing transmission. But of course, changing interactions is very difficult in a system, and the ultimate goal whether we're talking about something like misinformation or whether we're talking about biological virus, is to reduce susceptibility. So for a virus, we would use something like vaccination. But misinformation, we're seeing a lot more companies now roll out preemptive messaging. So rather than trying to frantically chase down every bit of content, actually present people with credible information up front. And I think that synthesis of ideas, as I've said, from finance to online content, we're seeing more in the study of violence, in social change, in innovations, really translating those ideas across fields. I think there's an enormous amount of potential to change how we approach these problems, because ultimately the next few years are going to be shaped by contagion. It's going to be biological, it's going to be social, it's almost certainly going to have economic impacts as well. And I think what we need is these tools and these skill sets so we can understand how these things have happened in past and ultimately change how they happen in future. So, thank you.
Hey Adam, thanks for that. If you have any questions for Adam, then please save them for the Q&A later on. Gave quite a great insight into social and biological contagions. So we're now going to move on to our final speaker, Emily Sappington, who is the product director for the assistant tribe at Babylon Health. So hey there, Emily.
Hi, great to be with you all today. My name is Emily Sappington, and yes, as mentioned, I'm the product director at Babylon Health on the assistant tribe. What we do on this tribe is essentially navigate conversational interfaces, natural language processing to help users reach healthcare more easily. Before this, I was product director at a small AI startup based here in London called Context Scout. And before that, I spent the bulk of my career at Microsoft. But I wanted to touch on something. The STEM was called out as the topic of this talk. And I just want to be clear, I do not have a STEM background. And I was excited to see so many students on the call, because the way I found my route and pathway into artificial intelligence is not your typical STEM route. I'll go way back to high school to talk about this. In high school, I did not do well in math. I did so poorly that I was nearly on academic probation and barely got by. And I'll lean into two themes for talking about my career and my pathway to find artificial intelligence today. And that it's been a combination of leaning into my strengths, and I recommend you all do the same, especially the students on the call, and also following an iterative design process. And I learned about this because after high school, I was able to graduate with honors and attend one of the top art schools, Parsons School for Design. In doing that, I also got my psychology degree at the same time, and at university focused on art and design. They teach you about the iterative design process. So if anyone's not familiar with what the iterative design process is, it essentially is a means of producing products and tools that are reflective of your user's needs. And so what happens is, if I were to say make a chair, I wouldn't have that chair designed, then sent to manufacturing, and then have friends and family and all sorts of other people sit in it for the first time. Instead, I would make a prototype, and I would try it out with people, and I would get their feedback, and I would find out what about the design was working, what was uncomfortable, and what I needed to change. And this is what I learned at design school in terms of the approach to how you should make products. And at the same time, I was learning this foundational approach to making products in an iterative way and designing and updating that design with feedback over time. I was also embarking on my career. And I think it's important to walk through the history of this, because not all folks start the way I did. My freshman year, my first year at university, I walked into the career services department and said, I'd like an internship. Now, on the one hand, I was fortunate that I was in New York City, where there was a plethora of places to intern. But I recommend this because most students don't actually pursue internships until their junior or senior, their last couple of years at university. Over the course of my time and my education, over 3 degrees, I had 8 different internships. And I'm going to walk you through a little bit of how, without realizing it, I was applying the iterative design process to my way of finding my own career over time. So what I did was, my first year, started an internship, went into it, and learned over time, you know what, I like some things about this company, and there are other things I don't like. And just like the iterative design process, I thought about those details that I'd like to see in my career. The fact that design was important to this company, that it was larger, and said, okay, what else could I do? That first one was in PR, marketing, advertising for design, nothing related to technology or AI. Then flash forward, I had internship after internship after internship at places like a wine magazine, at places like designing the website and the text for that, and places where I did exhibition design for museums. Towards the end, I also made my way to an digital advertising space. And what was great is I really did follow that iterative process all along the way. Each internship taught me something about myself. I learned, for example, that I wanted to be at a large company where I could learn from other people. I learned that I liked finding a place where design was valued, even if I was the minority designer there, if there weren't many people who did what I do. And so these are valuable lessons to learn along the way. And it just so happened that as I was iterating and as I was working on the things I liked, that I found technology. And someone who didn't do well in the STEM subjects and found it, frankly, quite a daunting field, it was really nice that over time, it was my own discovery and my own learnings that led me to technology and eventually artificial intelligence. I'll talk about my internships as they wound down, but one thing I want to note, I did 8 internships, and it's important to call out that for me, it was very important to make sure those were paid internships. I know there's a lot of students on the call, so I just want to acknowledge, I highly advocate and recommend all of you knowing your worth and making sure that you get paid for your contributions. There are some instances where you may get credit, and that's a different story, but just wanted to call that out. I think it's important that we take the time to remember that, as well as just talk again about the value of interning and trying places. It's not just that the iterative design process is a great thing. I also just want you to think, those of you who are good at math, think about how long it would take for me to have 8 jobs at 8 different companies and how many years that would take. Those of you who are near graduating, you may be thinking, well, I could try this or that, but you might worry that if you took a job, you would have to stick it out for a year. You'd want your resume to have that for a period of time. And so the nice thing about interning that I pass on to anyone in that age group is just that at least you get to try something for 3 months and walk away if you don't like it. There's not a commitment, there's no quitting, there's no firing. It's just a short engagement where you learn. And if you can't do that, I highly recommend you shadow and you learn from other people, get in the environment, see what they're doing, observe them, and learn as best you can. Okay, so let's speed up a little bit in the timeline. 7th internship or so, I know I want a big company. I know I want a place where design is recognized and appreciated. And by this point, I'd learned things. For example, I worked at a museum in New York City and designed exhibitions. Now, user experience wasn't very well known at the time, but I just knew that I enjoyed designing the way people navigate and move through a space. And that could be physical, emotional, and later I'd find out digital. I enjoyed finding ways to have them not hit dead ends, finding ways to make their experience more enjoyable, even before I knew what user experience or interaction design was. And then over time, I learned that technology wasn't as daunting as I initially thought, that Wine Magazine needed someone to code their website, and I figured it out. And so those of you, again, thinking about trying and iterating and testing, it's important to do that at a young age, because subjects that you may have written off early on might not be as hard to approach later on in your career. So my 7th internship then led me to realizing that I wanted experience in technology. So I got my master's at Carnegie Mellon, which has quite a strong background in computer science. I got my master's in interaction design, again, leaning into my strengths, knowing that that's my capability and that's what I bring to the table. And at Microsoft, in between the first and second years of graduate school, I got an internship with Microsoft. And that's where it stopped. That was my 8th internship. And for me, that was the confirmation that I'd found all of those lessons that I'd learned along the way through interning at different places. I finally felt like all the boxes were ticked in one place. So that was fantastic, because I felt like in my career I'd found technology, and that was great. But that still doesn't take you to understanding my career in artificial intelligence. So I joined Microsoft, and it was one of the first times in a while that I felt like my psychology degree was being used for good. Often one of the concerns I had working in advertising and things like that is that it was encouraged that I use my background in psychology to sell rather than to engage and entice users to have a good experience. So one of my first projects at Microsoft was to design touchpad gestures. That's just you using your hand on your trackpad like you all do millions of times a day, I'm sure. And in that process, I appreciated that though we're working in technology, it was still incredibly creative. To tell you a little bit about how that looks, for example, we needed to do user research, and I had probably 7 or 8 different size trackpads that would vary depending on the size of the laptop. So I brought people in, painted their fingers, and had them try the gestures I was designing. And literally, we were finger painting to design our trackpad gestures. But it was a brilliant combination of understanding the technology and leaning into my strengths of design, of psychology, and using the two to make a fantastic product. And we ended up getting a patent for that work, which was wonderful. Over time in my career, having that background in psychology, having that background in design, I've been known as this sort of input person who can understand how people input and relate to their technology. So from trackpads, I went to working on drag and drop for touchscreens, and we got a patent for that as well, as the technology was still quite new. The Surface Pen had just come out. We were looking at ways to use the pen and engage with that in a creative way. And then we were on the precipice of something big when someone said, would you like to work on voice? That for me was my foray into artificial intelligence, really on the experiential side. I started to learn about natural language processing and loved the fact that technology was going to make it easier for people to communicate. It was going to make it easier for my mother, who might have taken hours of explaining how to copy paste. She could quickly say, hey, Cortana, send an email. And it was wonderful to see that progress and see that through different modalities and through opening up technology, we were able to welcome a lot more people to the table. And that's really the side of artificial intelligence that I found my place in. It's finding a way to make computers more human, to make them more relatable, to make the dialogue you have with an assistant or a chatbot seem relaxing, especially in healthcare and medicine at Babylon Health, put you at ease, be that bedside manner that we can't always provide 24/7, and be that means that we can connect with people even through technology. So to think about my career progression, I think I would just want to pass on, especially to the students in the call, to not rule anything out. You don't know just because of your grades if you'll end up in a field that you don't expect at all, but also to remember to lean into your strengths. It's something that served me well, and to find places where you're supported. I appreciated that as I've gone into tech, I found communities and places where design and creativity is fostered and encouraged. And it's important to have an iterative approach to looking at your options out there, because you do have options, and it's important to think about, will I learn what I want from this opportunity, and is it growing me in the direction I'm passionate about in my career? For me, artificial intelligence has provided that in the way that I can teach computers to do tasks in a means that will be reminiscent of human interactions and in a way that helps people feel comfortable and feel at ease with their technology. That's about the end of my time. If anyone has further questions about the design of AI, the experience of AI, I'm happy to tell you about the fun meetings we've had, writing jokes with playwriters who've been hired to Microsoft, coming up with the personality of our assistant and our chatbot and what it means to write and to understand the personality of technology, and more fun things like that, because I think it's important to share that AI is more than just zeros and ones. Thanks.
Hey, Emily, thanks for that. It was actually nice to hear you talk about how you don't need to come from a technical background and the importance of doing internships. And 8 internships is a lot. So that's, I feel like that's super inspiring in itself. Hopefully our students can take away a lot of information from that. Just to say it again, if you have any questions, then please save them for our Q&A later on. I think we've got a 15-minute break now, and then we'll come back with the panelists for our question and answers. Yeah. Hey, Nisa.
Thank you. Hey, thank you. Thank you, Sunaina, for moderating that amazing discussion. And thank you again to all of the panelists. We are now going to take a 15-minute break, and we will be back at 3 p.m. with Sunaina, who will take some questions from the audience, rejoin with the panelists, and hear from them again. We'll see you at 3. Thanks.
Want access to more CogX videos? Subscribe now for free at cogx.co.